Recall in part 2 that we looked at a bridge circuit with generic boxes for components, and then we looked at a conceptual bridge in which we use switches that we could manipulate. And in this part 3 we're going to look more carefully at the devices that you might use, and in this case in particular we're going to look at diodes, and we're going to build what's called a half-wave rectifier with a diode. A diode is essentially a one-way valve for current. It only allows current to flow in one direction, as suggested by its symbol. Here's the circuit symbol for a diode, and this part here with the arrow-like structure suggests that it should only let current flow in one direction, in this case, this direction. Now, a diode is analogous to a flat valve or a one-way valve for fluid. So I'm going to draw a pipe here with a closed flat valve, and it's a flexible material that with a small amount of pressure stays closed. However, if we have a much greater pressure, the flaps open and allow fluid to flow. And a diode is analogous to a flat valve or this one-way valve. The diode switches on or allows current to flow when there is sufficient voltage across it. So we can think of it as a special switch with a potential across it, a voltage, and the switch closes if that voltage gets greater than a certain number. We can call it a threshold voltage. Let's plot how this works using something called an IV curve or an IV characteristic. Here we plot the current through the diode, I, as a function of the voltage across it. Now remember, a diode is a one-way valve. So like our flat valve here, we want a device that allows current to flow in just one direction but prevent it from flowing in the other direction. So that means for negative voltage, we want no current to flow. So the current is 0 here for negative voltage. However, once the voltage achieves a particular threshold, we want the diode to look essentially like a wire. So the IV characteristic looks something like this. So a diode is a switch that closes if the voltage exceeds a threshold, and this is usually something on the order of less than 1 volt. So maybe 1 volt is here. So this is the IV curve for the diode, and again the takeaway message is that it doesn't allow current to flow when the voltage across it is negative, but it looks pretty much like a wire with a small voltage drop indicated by this if the voltage becomes positive. We can use a diode to rectify current, and by rectify we mean keep the current going in only one direction. I'm going to draw a half-wave rectifier. Here's our diode. Here is the load, and we connect to it an AC source. Now this is very generic, but the idea here is that this diode only allows the current to flow this way. It does not allow it to flow the opposite direction. So let's plot what this looks like if our source is an AC source. So the voltage that we see between these two locations, call it Vs, is going to be different than the voltage that we see across our load, VL. Let's plot those. Here is our waveform as a function of time of the V sub s. So I will draw an arrow to this called V sub s, excuse me. And now let's plot what V sub L looks like. I'm going to change it to blue. And because it only allows current to flow in one direction, we're going to see that V sub L looks something like this. When it's positive, when V sub s is positive, V sub L will track it, because the diode here looks like a wire. But the diode prevents flow in the opposite direction, so that means when V sub s goes negative, V sub L will be 0. So we'll lop off the negative part of the waveform. Because of the rectification of the diode, property of the diode, then our load here sees only the positive half of the wave. So this is why we refer to it as a half-wave rectifier. In our next video, we will discuss the full-wave rectifier. That will be part 4 of this video series.